Today we discuss conducting polymers. Generally the polymers are insulators, but some exceptional polymers can conduct the electricity. That polymers that is known as the conducting polymers. A polymer which conducts electricity is known as conducting polymers. Example, polyaniline, polypyrrole, polyacetylene, etc. Next, classification of conducting polymer. Conducting polymer mainly classified into two types, intrinsically conducting polymer and second is the extrinsically conducting polymer. Classified into intrinsically conducting polymer and extrinsically conducting polymer. Intrinsically conducting polymer again classified into conducting polymer with conjugated pi electrons and second is the doped conducting polymer. Extrinsically conducting polymer again classified into two types, conducting elements filled polymers and second is blended conducting polymer. First, we can discuss intrinsically conducting polymer. Intrinsically conducting polymers due to the presence of extended conjugation within molecule. For example, polyacetylene. Polyacetylene is prepared by acetylene act as a monomer. N molecules of acetylene linking together polyacetylene is prepared. In polyacetylene contain alternate single and double bond. Double bond, single bond, double bond, single bond. That means alternate single and double bond. This alternate single and double bond that is known as the conjugation. This conjugation, this extended conjugation creating conductivity in polymer chain. That is known as the intrinsically conducting polymer. They have extended conjugation which is responsible for conduction. This extrinsically conducting polymer classified into conducting polymer with conjugated pi electron and second is doped conducting polymer. First one, conducting polymer with conjugated pi electron. The conducting polymer with conjugated pi electron, consider example polyacetylene. Polyacetylene contain extended conjugation. That means double bond, single bond, double bond, single bond, etc. This double bond contains sigma bond and pi bond. This pi bond, consider pi bond. Pi bond means pi electrons are overlapping together. This pi bond is generated by overlapping the pi orbitals forming valence band and conduction band. Valence, we already know what is valence band and conduction band. Valence band means the highest occupied band is called the valence band. Lowest occupied band is called the conduction band. That means this pi bond in which pi orbitals overlapping together generating valence band and conduction band. This valence band and conduction band are separated by a energy gap. Then conduction occurs when electrons jumps from valence band to conduction band. Then by thermally or photolytically. By thermally or photolytically, electron jumps from valence band to conduction band. As a result, the conduction occurs. That is known as the conducting polymer with the conjugated pi electron. Example, polyacetylene, polyaniline, etc. The second one, doped conducting polymer. Doped conducting polymer means the polymer undergo oxidation or reduction. As a result, a positive charge or negative charge is generated in polymer chain. That imparts conductivity. That is known as the doped conducting polymer. This doped conducting polymer again classified into two types, p doping and n doping. P doping and n doping. First, p doping. P doping means it is a oxidative process. It is done by oxidative process. In this process, some electrons from pi bond of the conjugated double bond. From the conjugated double bond, some electrons are removed. Then holes are created. Holes means positive charge are created. This positive charge can move throughout the polymer chain by the rearrangement of single and double bond. Consider polyacetylene. From conjugated double bond, some electrons are removed. First one electron is removed from conjugated double bond. But this double bond consider, then one electron is removed, a positive charge is generated. This positive charge that is known as the hole. This hole can move throughout the polymer chain by the rearrangement of the single and double bond. Then that imparting conductivity to the polymer chain, that is known as the p-doping. This positive charge polymer chain, that is known as the polaron. The charged particle formed by doping. This process is known as the doping. This charged particle formed by doping is known as the polaron. This polaron or mobile can move throughout the polymer chain by the rearrangement of the single and double bond. Hence, the polymer becomes conductive in nature. This oxidative process is carried out by Lewis acid like FeCl3. This process is carried out by FeCl3. Next, N-doping. N-doping means it is a reductive process. It is done by reductive process. That means reduction means some electrons are introduced into the polymer chain. In this type of doping, some electrons are introduced into the polymer chain. Then, introduced into the polymer chain, this process is carried out by Lewis base, example sodium naphthalide. This resulting the formation of a negative charge. Extra electron is added to polymer chain, that generating negative charge. This negative charged particle is also known as polaron. This polaron can move throughout the polymer chain, resulting conjugation. This polaron move through the polymer chain, which results the conjugation. That is the N-doping. N-doping means it is a reductive process. That means some electrons added to conjugated double bond. Then a negative charge is generated. This negative charge can move throughout the polymer chain, which is resulting conduction. That is known as the N-doping. Next, eccentrically conducting polymers. Eccentrically conducting polymers, that means these are the conducting polymers whose conductivity is due to the presence of external ingredients added to them. External ingredients is added to them, generating conductivity, that is known as the eccentrically conducting polymers. Then again classified into conductive element filled polymers, and second is the blended conducting polymer. Conductive element filled polymers means the polymers are filled with conductive elements such as carbon black, metal oxides, etc. Then generating conductivity, that is known as the conductive element filled polymers. This merit low cost, light in weight, durable and strong. That is the conductive element is added to polymer chain, generating conductivity. That is the conductive element filled polymers. And second is the blended conducting polymers. Blended conducting polymers, that means these polymers are obtained by blending conducting polymer with the conventional polymer. Conventional polymer means insulators. By blending means by mixing conducting polymers with the conventional polymer such as insulators. That generating conductivity, that is known as the blended conducting polymers. These polymers have better physical, chemical and mechanical properties. Can be easily processed. That is the classification of conducting polymer. So firstly, classified into intrinsically conducting polymer and extrinsically conducting polymer. Intrinsically conducting polymer again classified into conducting polymer with the conjugated pi electron, and second is the doped conducting polymer. Extrinsically conducting polymer classified into two: conducting elements filled polymers and blended conducting polymers. Next, examples of conducting polymer. First example, polyaniline. Polyaniline is also written as PANI. P, poly, ANI represent aniline. PANI polyaniline. First, the preparation of polyaniline. Polyaniline prepared by oxidation method. This oxidation done either chemical method or electrochemical method. First, consider chemical method. In chemical method, an aqueous solution of ammonium persulfate is added to solution of aniline dissolved in hydrochloric acid at a temperature of 5 degrees Celsius under agitation. After an hour, a precipitate is formed which is removed by filtration. The obtained polymer is washed with ammonium hydroxide solution and dried. Ammonium persulfate acting as a oxidant. This ammonium persulfate is added to aniline solution, that is aniline is dissolved in hydrochloric acid, into which ammonium persulfate is added. After an hour, the precipitate is formed. That precipitate is removed by filtration. That obtained precipitate is washed. That is the polyaniline. This is the chemical method. Next, the electrochemical method. Electrochemical method, that is it is prepared by electrochemical oxidation by dipping platinum electrodes in acidified aniline solution. Applying the potential 0.7 volt. Polyaniline film is formed on the surface of the positive electrode. By dipping the platinum electrons in acidified aniline solution, applying the potential between anode and cathode, then polyaniline film is formed. Here also oxidation of aniline occurs. In two methods, the reaction is aniline, that is CH5NH2, undergo oxidation. Then the product is CH5NH N times plus N by 2 H2O. This is the polyaniline. That is the preparation. Next, the properties. Properties of polyaniline. Polyaniline is also known as the synthetic metal. It has conductivity like metals, metallic luster and metallic sound. Polyaniline has lightweight and mechanical flexibility. Third one, it can be doped for increasing conductivity. Fourth, highly stable in air. Sixth one, soluble in all organic solvent. Fifth one, soluble in all organic solvent. Sixth property, polyaniline can show different colors in different oxidation state. Hence, it is used in sensors. This doped polyaniline is a good conductor comparable to copper, but its original form polyaniline is a semiconductor. These are the property. First property, polyaniline has the conductivity like metals. It is lightweight and mechanical flexibility. They can be doped for increasing conductivity, stable in air, soluble in all organic solvent, which shows different oxidation state. Hence, it is used in sensors. Next, uses. First use to make lightweight rechargeable battery. Second one, it acts as a shield for electromagnetic radiation. Third one, it can be used in chemical vapor sensors, supercapacitor and biosensor. Fourth one, it is used for corrosion protection. To make lightweight rechargeable battery, act as a shield for electromagnetic radiation. It can be used in chemical vapor sensors, supercapacitor and biosensor. And fourth one, corrosion protection. That is the first example, polyaniline, preparation, property and uses. Okay, thank you.